So in this session, we are going to discuss about distributed systems, fifth unit. Okay, fifth unit is fully based on case studies. In that, already we discussed about fourth unit, fault tolerance and services. Okay, so in the fifth unit, these are the topics we are going to discuss: distributed object-based systems, CARBA, Common Object Request Broking Architecture, and distributed file systems, and Sun network file systems, and Andrew file systems, Enterprise Java Beans. And fractals. Another topic is Gini. These are the topics I will discuss in the fifth unit. Okay. So in that I'm going to explain Sun Microsoft Systems. Okay, Sun NFS. Okay, Sun Microsystems and Network File Systems. Okay, in that Sun NFS. So NFS is a distributed file systems protocol. So originally developed by Sun Microsystems. Sun NFS is the network file systems. It is developed by the Sun Microsystems. So NFS version 2 was the standard protocol followed for many years, designed with the goal of simple and fast server crash recovery. Okay, this main is purpose is we can easily access data very fast, and if there is any crash means we can easily recover from the file system. That's the concept of Sun NFS. Okay. NFS allows a user on a client computer to access files from a remote server. With the help of remote server, we can access the files. Okay, with the help of remote procedure call, we can access the access file from the network file system, Sun network file systems. Okay, so NFS client and server communicate using remote procedure call. In that, in the Sun network file systems, client and servers are communicate based on the remote procedure call. So remote procedure calls already we know. The client send the request to the server. The client side client send the request. The request will be with the help of client side stuff. It automatically converted into mastering process, and then send to the server. Server perform the unmasking process and process the request and send back to the response to the clients. Okay, so in that we have two types of protocols: a stateful protocol and a stateless protocol of the distributed network file systems. In the stateful protocol, make things complicated when it comes to crash. Okay, stateful protocol means if any servers or any devices crash means it's difficult to make the recovery. Okay, in a stateless protocols means if you are maintaining the stateless protocol, the protocols are designed to designed so as to not store any state information on the server. It does not store the state information about the server. Okay, this is stateless protocol. Okay, so another one, this is a diagram for architecture diagram for Sun network file systems. In that way, this is client computer, this is server computer. How client can send the request to the server computer and get this file from the server computer. Okay, in that we have a system calls, that's a unique system calls. Based on that, there will be applications program. We are sending the some system calls to the virtual file systems. Virtual file systems can maintain the files to access. If it is local means it locally to access the files from the individual systems. If it is not available means it go for the network file systems in the help of remote procedure called that the remote concepts. Okay, it's with the help of NFS protocol, stateless and stateful protocol. It sends the request to the server computer. In the server computer, the virtual file system is available. So based on that, it we can identify the location and send the data to the client computer. This is architecture of Sun network file systems. In that virtual file systems. So virtual file systems are nothing but distinguish between the local and remote files. So file identifiers used in NFS are called file handlers. In the file handle method is based on three concepts. One is a file system identifier, inode number of a file, and the inode generation number. In that file system identifier is nothing but a unique number that is allocated to each file system when it is created. If the file is created, means the unique number is created, that is called as file system identifier. Inode number is nothing but locate the file in these systems and also used to store its attribute, and inode numbers are reused after file is removed. Okay, so based on that inode number we can locate the where the file is stored. Okay, another one is inode generation number. Is nothing but increment each time the inode number are reused after the file is removed. It is incremented based on the inode I value will be the inode number. That's a particular file is reused. The number will be reused means it will be incremented number. The one time use means number will be added 1 plus 1 plus 1 plus 1 plus like that. It increment the number. That means it identify the number of times the inode number is used. Okay, reused. It's a concept of file handling in the NFS. Okay, in the client side, client integration, Sun network file system client integration. The NFS client module cooperate with the virtual file systems in each client machines. If the file is local, access the unique file system for the local files. If the file is remote, NFS client send the request to the NFS server. That is already we discussed diagram. If it is local, it sends the data. If it is not, it send the NFS file systems. It's in the send the request to the NFS server. So NFS server interface. In the NFS server interface, NFS server is stateless and does not keep files open on behalf of its client. Okay, it does not, because it's just stateless. So it does not keep files, okay, open behalf of the client. Okay, that is a NFS client. In that we have the many file operations. Already we discussed the file operations in the previous class. And the server must check the user's identity against the file success permissions attribute on each request. This is some of the file operations. Lookup, that means returns file handle and attributes for the file name in the directory. Okay, and then create a new file, and then remove a file name, and then get attribute, returns the file attributes, and then set attribute, and then read, write, and then rename, and then link. These are the some of the file operations in the Sun network file systems. And then systems link, read link, and then make directory, and then remove directory, and then read address. These are some of the operations followed by the Sun network file system concept. Okay, and then Sun network file system have the naming process. Naming is a mapping between local and physical objects. For example, user refer to a file by a textual name. It is mapped to disk block. Okay, so in that we have path name and the mount service. So path name is nothing but file are named by some combination of machines or host name and path name. This may be used as a server side. Okay, and then mount service mount the remote directories to the local directories. The mount operations based on local host and the remote directory and the local directory. In that client want to mount the data located in the server means the client we have root, and then we have many subnodes or subroutes. So based on that user we have students means with the help of remote procedure called remote mount, it send the request to the server with the help of remote procedure call, and then it identify the path and get the data in the mount the located file available in the server side. And also in the other node, the staff, here also the user will be identified based on the remote procedure call in the server too. This is mounting operations. Mounting operations have three types. One is a soft mount, a hard mount, and a auto mount. Soft mount, time bound is there. Yes, soft mount is that time bound is there. It send the failure messages. That means based on the particular time you have to mount the root of the files. And the hard mount, so no time bound, so you have to retry the request until it is satisfied. Whether until it is satisfied, you have to retry the same process. That's a hard mount. And auto mount is nothing but mount operations done on demand. Based on the demand, based on the request, mount operation will be done. That's called the auto, that is called auto mount. Then client catching and then server catching. So client catching is nothing but the NFS client module catches save the result to reduce the number of requests transmitted to the server. A timestamp based method is used to validate the checked blocks before they are used, and then securing NFS with a careful. This is called a client side catching. And the server side catch. The use of servers cache to code recently read disk block does not raise any consistency problems. And the server cache, the recently read data blocks will be identified easily. So data in write operations system from the client is stored in the memory cache at the server and returned to disk before the reply is sent to the client. So this is called a write through catching. Based on the write operations, we can write the data, that store the data and retrieve the data from the server cache. data in write operations is stored only in the memory cache. It will be returned to the disk when commit operations received for the relevant file. Okay, this is server side cache. That's all about. Thank you. Okay, that's all about Sun Network file systems. Thank you. Okay.